So this is part 2 of the tutorial of Hypermesh composite analysis. So before we begin processing or post-processing, I would like to show one thing. I would like to show the ply 1 to 4, how to visualize ply 1 to 4. So first we will go to preference and graphics, and in here ply visualization thickness factor we had already set it 100, so set it to 100 and return. And now click on ZX. Now click on this two-dimensional detailed element representation, and now click on this composite layers with fiber direction. Now you can see 4 layers are here, but it is not as per this color. In order to visualize these plies in these colors, go to this option by component and choose by property. So now you can see each ply is according to one color. So you can see the first ply, the ply on the top is this ply 4, then ply 3, then ply 2, and then ply 1. In order to see if this, in order to see what is there inside of this composite, we can use mask option. In order to mask, go to tools and mask. So go to tools, mask. Now you can choose elements and you can mask. So if you choose this element and if you mask, now you can see that this element has been masked. Similarly, you can choose another element. Similarly, you can use hold shift and drag with left mouse button, and you can mask the elements, and you can see that the orientation of ply inside of the composite as well. Now you can use this option unmask all to unmask all the elements. Now you can see all the elements are back in place. Now you can click return. So this is how you visualize the plies by color. What you have to do is choose the option by property over here. So now we will run the analysis. In order to run the analysis, go to analysis tab, click on OptiStruct. Now here in the export options you have to choose all, and this is important that you have to choose export options to all, and in the run options you have to choose analysis. Since we are running analysis, it is essential that in run options you have to choose analysis, and memory keep it by default, and click on this OptiStruct. Now the analysis will start. It may take few seconds or maybe few minutes, so we will have to wait. So you can see that analysis has been completed, and end of solver screen output and job completed. If there are some errors, that will be displayed here. In that case, you have to close this, go back to the tutorial and see what is the mistake and rectify it. And you can see, since we have given default memory, the amount of memory allocated for the run is 130 MB. This run will use in-core processing in the solver. So by default, it will take 130 MB of the RAM to run this analysis. Now in order to output the results, in order to see the output or in order to see the results, click on this results. Now click on apply. So this option will discard all current window model data. Continue applying the model. Yes. Now click on XY. Now click on this button which will be contours. Now in here you can choose the result type, displacement, magnitude, and so on. You can choose displacement, you can click apply. So you can see the displacement here. Displacement varies linearly here. Now what we have to see is the stresses. Now here choose the option composite stresses. Once you choose composite stresses, go click on this 1 meter stress and choose normal X stress. Now here in these layers, click here and you can find your ply 1. Now you can click apply. Now you can see the stress of ply 1. You can see here the stress in ply 1 is 1.557 e to the power 8. Similarly, you can click ply 2 and click apply. Now you can see the value of stress is 3.015 e to the power 6. Similarly, in ply 3 you can click apply and you can see the stress in ply 4. If you want the maximum value, you can choose maximum in the layers and you can click apply. So it will show the maximum stress is 1.557 e power 8. And if you want the minimum value, you can choose minimum and you can click apply. Now you can save this if you want. So let us go to the folder and see what files has been generated. So let us take a look at some of the files in this folder. Now this file composite.out, this is you can see this is an output file, and its format will be ASCII output, and this file contains specific information on the file setup, the setup of your optimization problem, estimate for the amount of RAM and disk space required for the run, information for each optimization iteration, and compute time information. You have to review this file for any kind of warnings and errors. So you can see the total number of grids, total number of elements, and total number of degrees of freedom. So you can see total number of elements 400, which are C-quad 4 elements, and SPC is single point constraints is 1, and cards 1 card pcomp. So you can see some of the parameters here. So you can see the analysis has been completed, and the memory has been used is 100 MB here, and 30 MB of scratch space. 30 MB of scratch space has been used here somewhere. Yeah, RAM scratch area is 30, so total 130 MB has been utilized. Here 130 MB was utilized. So analysis completed. So you can see the CPU time is 0, elapsed time is 4. So it didn't take much time for computation. Now the next file is composite.res. This is a Hypermesh binary results file. So composite.res, this is Hypermesh binary result file. Now composite.stat. So this file is a summary of analysis process, providing CPU information for each step during the analysis process. So you can see the time spent in module CPU is equal to 0.03. So you can see the time that has been spent for this analysis will be displayed here. And one more file is composite.h3d, and this is the Hyperview binary result file. So once you finish your processing, you have to this file you have to load to see the results. For example, you can click click load result files over here, and once you click on this option, and you have to click this .h3d file, click open, click play. So this is how you load result files manually. In case you don't click this, instead if you close this and now you want to open it, so for that you have to go here and click load result files and click on the .h3d file, this .h3d file, and then click on apply. So that's it for this tutorial. Thanks for watching. If you have any doubts, please comment below, and if you like this video, please give a thumbs up and subscribe and share. Thanks for watching.